Hi, I'm Jack, and this is the sixth video in this series about my Computer Science A-Level NEA. I scored 70 out of 70 for my project, and hopefully I can help you get a high score too. For my NEA, I decided to build a computer game with some basic AI based on an old abstract strategy board game. In this video, we'll be looking at the design section of the NEA. Okay, so this section is an important part of your NEA and will be the blueprint for your project. It should demonstrate to examiners that you had a clear and logical plan to solve your problem, rather than just stumbling into the coding and hoping for the best. The main goal of this section is to show how your solution is structured, and you'll be using plenty of flowcharts and pseudocode to help you achieve this. I'll include a link to the flowchart, the website I use to make my flowcharts below, so you can use that if you want. I started this section with a diagram of my user interface design, more specifically the main menu. And it's got annotations where needed to show any features. I then describe what it is in the text, everything it has on it, and link it back to my success criteria where possible. I do pretty much the same thing for the instructions page, the game screen, and the win or lose screen. Your UI should be functional and intuitive with clear layout and labels, because you want to meet those usability features criteria, but don't spend too much time on making it look beautiful, because you don't get any marks for that. Then we've got a flowchart to show the transitions between the different screens. And I wrote a few paragraphs detailing the usability features of my design. These include things like large buttons, use of sliders to enforce sensible minimums and maximums, and highlighting the winning pattern in the game so you can tell how the game was won or lost. I then get some stakeholder input to assess their thoughts on design. I won't describe this any further as I already have a separate video on stakeholders, so go and check that out if you want more detail. The next section is algorithms and begins with a decomposition of the solution code. You can see I've clearly split the problem down into individual functions and classes. I actually ended up doing most of this after I'd completed the development section to ensure it was consistent with the code I ended up writing. I then have a flowchart of the simplified game loop showing the main processes of using my game. After this, under the subheading functions, I then get more into the pseudocode, which I use to show how I will program drawing the board in pieces, handling inputs, button functions, and the AI move generation. Again, I must admit to writing this after I wrote the actual code so I knew it'd be accurate, even though that rather does defeat the point of planning your project in advance. I ended this part with a flowchart to show AI move generation and a diagram of port forwarding. After this, we have the class structure, where you should have a number of class diagrams describing the methods and fields of the various classes you're going to use in your solution. Following on from that, we have subroutines. Now this goes into great detail on some of your more important functions and methods, explaining exactly how they should carry out their intended method. I also included some pseudocode for some of these. I chose to primarily focus on the functions that allow the user to play the game, such as displaying the board on the screen, carrying out a move, checking a move is legal, and detecting when a player has won. Following on from that, I have a table of inputs and outputs. This shows you a plan for the processes that will translate each input into an output. The first column is the input the user does, the second is the process that happened, and the third is the actual output that should occur afterwards. Following on from this, we've got a table of key variables to document, justify, and map out the data required for all of the system's functionality. First column should list the variables, the second column states the data type, and the third column describes what it's used for and why it's needed. After that, we've got validation. This demonstrates that the program is robust, secure, and reliable rather than just barely functioning so long as the user does everything correctly. Shows the system can handle unexpected user input and errors in a controlled, planned manner rather than just crashing or presenting unexpected behavior. One of the things I chose to talk about was the validation of my numeric input boxes, as I need to ensure that valid values, such as a negative timer duration, wouldn't be accepted. The final part of this section is the testing method. I begin by generally talking about the importance of testing, what needs to be tested, and how I'm going to do this throughout the iterative process. You should ensure any test data you select is thorough and designed to try and provoke errors, for example by including values on the exact limits of what an input should accept. You should then justify how you've chosen to test the test data. Following on from this, I then have test tables for each of my iterations detailing the functionality to test, how to test it, and the expected result. At the end, I then have a summative test table for testing the whole system. I used a 3-column table where the first column describes the core features, like being able to move pieces on the board, the second describes how it can be tested in evidence, and the third column gives the expected result. I actually changed this table into a 6-column table when I come to do the actual testing. So you can see that in my summative testing video if you want to check that out. I end this section by talking about stakeholder testing, explaining where, when, and why I'm going to get them involved throughout the development process. So that's the end of the 6th video in this series. There's a link to my NEA in full below if you want to check it out. And in the next video, I'll be looking at the development section of the NEA.